Around 400,000 Go Devil engines rolled out of American factories during World War II. And what's incredible is that almost nothing about the design ever had to change. That alone tells you the entire story. The Jeep Go Devil didn't earn its reputation by chasing high-tech engineering. It became a legend by refusing to overcomplicate what didn't need fixing, while everyone else was trying to build something more sophisticated. Picture this scene. It's June 1944, Normandy. A line of jeeps pushes through a flooded river crossing. Water climbs over the grille, spills across the hood, and chokes the engines. Some sputter. Some stall. Silence rolls across the convoy. But then, minutes later, soldiers are back under the hoods, draining what water they can, removing a couple of spark plugs. And suddenly one Go Devil after another roars back to life. No waterproof kits, no special procedures, just pure, honest engineering doing exactly what it was designed to do. That wasn't luck, that was the Willys Go Devil. Today, we're diving into the engine that became a backbone of the Allied war effort, the 130. 4-cubic-inch flathead 4 that carried soldiers through deserts, jungles, mountains, and frozen battlefields. The little power plant that helped define the Jeep legacy we still recognize 8 decades later. To understand why this engine mattered, we need to go back to 1940, when the U.S. Army issued one of the most demanding challenges in automotive history. Build a lightweight reconnaissance vehicle, under 1,300 pounds, capable of 50 miles per hour, able to hold a quarter-ton of gear, and durable enough to survive places where normal vehicles simply died. 3 companies answered the call: Ford, Bantam, and Willys Overland. Bantam had the design, but not the production muscle. Ford had the factories, but their prototypes were too heavy. Willys had something neither of them had: an engineer named Delmar Barney Roos, a man who once tuned engines for Studebaker's racing program. And this is where everything changed. While Ford and Bantam pushed for more power with complex overhead valve systems, Roos took a completely different approach. He didn't try to build the fastest engine. He built the most dependable one, a rugged, tractor-style flathead, adapted from an abandoned Willys passenger car project. What others dismissed as outdated, Roos saw as a gift. The Go Devil was simple by design: no overhead valves, no push rods, no rocker arms, no delicate timing chain. Everything happened down in the block. By 1941 standards, it wasn't modern, but it was bulletproof. Let's look at what made it special. This little monster displaced 134.2 cubic inches, about 2.2 liters. A long-stroke design built for torque, not high RPM. Compression ratios were low, between 6.41 and 7.41, so the engine could run on the awful fuel available in war zones. Horsepower? About 60 during wartime, nearly 90 in post-war civilian versions. But the real magic was torque, 105 to 100, and 14 lb-ft at just 2,000 revolutions per minute. In a 2,300-pound Jeep, that meant real climbing power. Durability was baked into the metal. Thick, cast-iron cylinder walls, a forged steel crankshaft with massive bearings, a gear-driven camshaft that could run practically forever. Even the oil pump and water pump were gear-driven. No belts, no chains, no fragile parts to fail. Roos deliberately used loose bearing clearances, so the engine could survive contaminated oil full of sand and dirt. The radiator held an enormous 11 quarts, enough to keep the engine alive even with bullet holes. Soldiers often ran Go Devils for miles, stopping only to refill water whenever they could. And what the engine didn't include was equally brilliant: no hydraulic lifters to clog, no aluminum parts to warp, no sensitive fuel pump, just a simple vacuum system. A single-barrel Carter Willis carburetor with only a handful of moving parts. Then came the torture tests. At Aberdeen Proving Ground, the Army did everything imaginable to break these engines, 100 hours at full throttle running underwater with snorkels. Neuro oil tests: seize the engine, refill it, start again. Poured directly into the fuel. Freeze tests at 40 degrees Fahrenheit. Hill climb so steep the Jeeps flipped backwards, the Go Devil kept running. And in real combat, North Africa roasted engines at 130 degrees Fahrenheit. The Ardennes froze them at 20 degrees Fahrenheit. The Pacific soaked them in corrosive salt water. Italy forced them up endless mountain climbs. Still, they ran. Mechanics loved them because everything was accessible with basic tools. Valve adjustments took minutes. Full rebuilds could be done on a workbench with a chain hoist. And thanks to Willys' smart part sharing, components were interchangeable with engines going back to the 1930s. By the end of the war, Willys had built 368,715 Go Devils. Ford added almost 278,000 more under license, over 646,000 engines, and only one major design change, a stronger oil pump drive gear. After World War II, the Go Devil kept working. In the CJ2A, on farms, in generators, on boats, on construction sites, anywhere people needed an engine they could absolutely trust. Insurance records from the 1950s showed most Go Devils lasting 85,000 to 100,000 miles. Astonishing for the era, with some passing 200,000 miles on basic maintenance alone. Competitors couldn't match that reliability. Ford's aluminum heads cracked. Bantam's overhead valve engines needed constant adjustments. International Harvester built a stronger engine, but it demanded premium fuel and high-grade oil, luxuries the battlefield didn't offer. What made the Go Devil different was simple. It removed complexity. It removed fragility. It removed anything that could fail. Low compression meant it could run on terrible fuel. The kind soldiers joked wasn't even gasoline. The Go Devil wasn't just an engine. It was a symbol of wartime ingenuity built on the idea that simplicity, not sophistication, wins battles. The Go Devil's durability wasn't just a matter of rugged components. It was a triumph of clever engineering that embraced imperfection. Its oversized bearing clearances allowed the engine to function, even when the oil was contaminated with dust and grit. The all-iron construction shrugged off extreme hot and cold temperatures, and the use of gear-driven components removed the need for constant adjustment. In essence, it was built to keep running even when conditions were so bad that most engines would have already failed. But the true genius behind the Go Devil wasn't limited to its mechanical resilience. It also excelled in how easily it could be manufactured. Because the design was intentionally simple, factories didn't need highly skilled machinists or precision tooling. These engines could be built on standard equipment with minimal finishing work and often went straight from the assembly bench into active duty without any special break-in procedures. Cost-wise, it was astonishingly efficient. In 1942, Willys could produce each Go Devil for just $185. Ford, using the same design, spent around $195 due to higher labor costs. To put that into perspective, a single Rolls-Royce Merlin aircraft engine cost over $10,000 at the time. For the price of one Merlin, the military could equip 50 Jeeps with Go Devils. Barney Roos also understood the human side of war. He knew engines would be maintained by soldiers who were cold, exhausted, or under fire. So he made everything simple and foolproof. The oil filler neck was impossible to miss. The dipstick was long enough to guide itself in, and the distributor only fit in one orientation. Even the spark plug wires were cut to specific lengths to prevent mix-ups. Every detail assumed the mechanic might be working in chaos. Real battles showcased this brilliance. During the Battle of the Bulge, Jeeps of the 101 Stones Airborne ran virtually non-stop for over a week in bitter cold, with nothing more than water and alcohol in. The cooling systems. The engines were covered in combat debris. The oil was never changed, yet the Jeeps kept moving. In the Pacific, Marines repeatedly drove Jeeps through seawater during amphibious operations. While the salt water corroded the bodywork and electrical systems, the Go Devil kept firing even after ingesting water into its cylinders. One story from Italy tells of a Jeep struck by shrapnel that tore open its oil pan. Soldiers stuffed the holes with bits of uniform and wood, filled it with whatever oil they could scavenge, mixed with olive oil from a local farmer, and still drove nearly 50 miles back to base. The engine survived. For something so simple, the metallurgy was surprisingly well thought out. The engine block used high-nickel cast iron, giving it natural resistance to corrosion. The forged steel crankshaft was heat-treated to precise hardness levels. Valve seats were hardened using induction processes so they could handle extremely low-quality fuel long before unleaded gasoline was common. The oversized cooling passages allowed debris, mud, and scale to circulate without clogging. Even the cooling fan was designed so that if a blade bent, it would simply push less air rather than destroy the radiator. The ignition system was equally robust. The distributor was sealed against water intrusion up to a depth of 3 feet. The coil was embedded in tar to isolate it from vibration. The spark plugs were standard agricultural types, available almost anywhere in the world, and diagnosing the entire system required nothing more than a basic screwdriver and a bit of wire. Modern testing shows how overbuilt the Go Devil really was. Analysts estimate that the bottom end could withstand nearly 200 horsepower, 3 times its intended output. The valve layout was conservative enough to allow 6,000 revolutions per minute operation despite being designed for 4,000, and the cooling system could theoretically handle the heat of an engine twice its size. None of this was accidental. Roos had studied what killed engines in World War I: poor maintenance, filthy environments, and rushed repairs. So he built huge safety margins into every component. When a Go Devil did fail, it was almost always due to something external, a hose, a belt, or a coolant leak, not the engine itself. Production methods were just as ingenious. Willys engineered the Go Devil to work with the machine tools they already owned, avoiding costly retooling. Engine blocks were cast in small batches, machined on equipment previously used for passenger cars, and assembled on fixed stands rather than moving conveyor lines. It was modular, flexible manufacturing decades before the term existed. The supply chain was equally pragmatic. Instead of relying on specialized automotive suppliers, Willys sourced parts for companies that made farm machinery, industrial equipment, and plumbing materials. If one supplier fell behind, several others could immediately take over with minimal changes. Quality control was simple but strict. Every 100th engine was completely disassembled for inspection, and every 1,000th was run to destruction. Failures were so rare that some engineers never witnessed one during the entire war. When Willys later tried to replace the Go Devil with the F-head Hurricane engine, the results proved how exceptional the original was. The Hurricane offered slightly more power thanks to overhead intake valves, but it was more complex and less dependable. Even after the new engine was introduced, military officials continued requesting Go Devils for years. Today, engineers still admire the Go Devil for its almost accidental perfection. Its long stroke layout minimized wear, the flathead combustion chamber resisted knocking, and the gear-driven components removed the most common failure points. Restoration experts say the Go Devil is easier to rebuild than engines from the 1980s, and original parts from the 1940s still fit perfectly because tolerances were so consistent. The numbers speak clearly. Out of the roughly 646,000 Go Devils built during World War II, around 50,000 are still running. That means about 8% of them survived 80 years, an astonishing rate when compared to engines from the 1960s, of which less than 1% remain in operating condition. The Go Devil didn't just last, it refused to die. Its long-term impact was enormous. The military saved the equivalent of nearly $1 billion in today's money, because the engines needed so little maintenance. After the war, a thriving global parts and service industry grew around the design. Jeep dealers built strong reputations because their vehicles rarely required major repairs. The Go Devil set the foundation for the entire off-road vehicle industry and inspired icons like the Land Rover and Toyota Land Cruiser. Even motorsports benefited from it. Early Jeepster racers and lightweight speedboats used modified Go Devils. Hot rodders discovered the block could handle nitromethane and extreme compression. With the right overhead valve conversions, they were pushing close to 200 horsepower. What began as a low-speed utility engine became a secret weapon in racing simply because it was built so tough. In a world where technology grows more complicated each year, the Go Devil stands as a reminder that simplicity has power. Barney Roos didn't ask how many features he could add, he focused on what he could remove while still meeting the mission. That mindset created an engine that helped win a war launched a global brand, and continues running 8 decades later. It proved that real engineering excellence isn't always about more horsepower or the latest innovation. Sometimes, it's about building something that never stops working.